Hi, welcome to my video on the definition of continuity. Definition of continuity. A function is continuous in a given interval if there is no break in the graph of the function in the entire interval range. So let's do some examples to show you that. Let's draw a line, which is a linear function. Notice on this line there's no break, it's continuous. And we draw a parabola, which is like this. Parabola is opening up and it's continuous at any point for the value of x. And we draw an absolute value, which is negative, so it's going downwards, so that's continuous on all values of x. And we can also draw an exponential graph, a growth graph, which goes like this, and that's continuous on all values of x. And we also can do a square root one, which starts here and opens this way, and that's continuous starting at this value of x, whatever this is, and moving on, so it's continuous at all points. And we can also have a log, which has a vertical asymptote, and the log does this, opens like this. The vertical asymptote is whatever you want, x equals 2, 1, but this is a log, it's continuous. So all these are continuous, there's no break in the curve. Now, not continuous, notice that at this point here, when x is 2, y is 2. When x is 2, right here, y is negative 1. So this is not continuous at x equals 2, because there's a gap or a break at 2. So from the right it comes down to 2, and on the left it comes to right here as it goes to the right, the y value goes to 2. Right here, as it comes from the left, the y value goes to negative 1. So it's not continuous at x is 2. Right here, this is not continuous at x equals 1. Right here, the hollow dot. And get back, this point is solid, so that point is included, and this is hollow, so this point is not included. And this is, if you come in from the right, it goes to 1. As you come in from the left, it goes to negative 1. So this is not continuous at x equals 0, because 0 has a value of 1, and 0 here has a value of negative 1, the limit. Remember, the limit is what it approaches as it goes to the left, and it comes in from the left, comes in from the right. And this one is not continuous at x equals 3. X equals 3 is a vertical asymptote, so it's not continuous anywhere on this vertical asymptote. And right here, x also equals 3. That is not continuous. So it's a hollow here, and when x is 3, y is 1, this point is included, but these 2 points are not. And right here, at x equals negative 1, negative 2. So it's not continuous at the point x is negative 2, y is negative 1. So continuous and not continuous. Let's continue. We have a graph here. Determine if the f of x, this is the f of x, the y value, is continuous at x equals negative 3. X is negative 3 here, is solid here, open here, so no, is not continuous. And when x is negative 2 is right here, so this is the point, and this point is included, so yes, it's continuous at 2. So as it comes in from the right, like this, it goes to this point. As it comes in from the left, it goes to this point, so it's included. At 0, as you come in from the right, it gets 2. As you come in to 0 on the left, you get a 2, so answer is yes. These are solid dots, so the point is included. And when x is 2 here, this point is hollow, it's not included. So it's no. Is it continuous? No. It's not continuous, because the point is hollow and is not included. Number 2, what value of x is the g of x discontinuous over the interval? So from negative 3 to 2, including negative 3. So from negative 3, which is right here, up to 2, which is here. So what value of x is the function not continuous? So the value of x is right here. X is 1. So when x is 1, this is a hole in the graph, so it's not continuous. It's hollow. Now we have the h of x equals 2 over this quadratic. So that's the h of x equals 2 over. And we factor here. We have a quadratic, so it's x and x. Factors of 5 are 5 and 1. Product is negative, sum is negative, so it's a negative 5 plus 1. So that means if x minus 5 equals 0, x plus 1 equals 0. We cannot have 0 in denominator, so when x is 5 or when x is negative 1, we have 0 in the denominator, and 0 in the denominator of fraction is undefined. So it's the values of x are x is 5 and x is negative 1. This function is not continuous. Let's continue. For each below, state the values of x for which the function is continuous. F of x equals mx plus b is a linear function. So a linear function is a line. So it's what values of x is continuous on all real values, all real numbers. This is a parabola, and ax squared plus bx plus c is a parabola, and this parabola is continuous on all values of x. This is an exponential, and the base is not 1, base is greater than 0. So when the base is between 0, when the base is between 0 and 1, we have the base is like a half. Then we have a decay curve that's doing this. Or if the base is greater than 1, we have a growth curve, and a growth curve is doing this. So on any of these curves, so the values of x on this curve is real numbers, and the values of x is on the growth curve is the set of real numbers. And h of x is 1 over x minus c. So x minus c is equal to 0. X is equal to c. So whatever this value of c is, so the value of c, it's undefined. So the values which is continuous is x is not equal to c. So whenever x is not equal to c, it's continuous. To give an example of that, 1 over x minus, let's say, 2. So that's the vertical asymptote at 2, which is here. So on this side, as x goes to infinity, 1 over x minus 2 goes to 0. So as if we have a 3 right here, 1 over 3 minus 2 is 1 over 1, which is 1. A 3 gives us a 1. So this curve is doing this, approaching 0, and it's on this side. When x is equal to 0, we get a negative 1/2. So this curve is doing this. Again, as x approaches infinity, the y value approaches 0. And as we get closer and closer to x equals 2, it goes to positive infinity on the right, it goes to negative infinity on the left. So this is continuous at all values except x, and this one, x is not equal to 2. So when x is 2, it's discontinuous. It's not. And that's a review of continuity. That's my first video on continuity. And again, if you like my video, click the like button, click the subscribe button if you wish. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. And it's the content that's on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.